Good morning, sir. This is B. Pujita from CSC B section. Here is the PPT of my engineering physics. Next, my topic is sources of electrical resistance. We are going to outline. This outline we can learn about PPT. First, introduction to electrical resistance, lattice vibrations, temperature dependence, material independence, length and cross-sectional area, resistivity, impurities and defects, series and parallel circuits, frequency dependence, practical applications and importance of minimizing resistance. Conclusion. Introduction. Electrical resistance is a fundamental property that measures how much a material opposes the flow of electrical current. It's typically denoted by the symbol R and is measured by the ohms with the symbol this. And next, materials with high resistance impede the flow of current, while those with low resistance allow current to flow more easily. And next we are going to sources of electrical resistance. There are various sources of electrical resistance. In that some are discussed in the PPT. Electrical resistance due to lattice vibrations. First, and the electrical resistance due to lattice vibration is a phenomenon of a phonon scattering. In a crystalline lattice, electrons moving through the lattice can collide with lattice vibrations phenon, leading to the scattering effect and increases the resistance of a material. This is a significant factor in determining the material, particularly in semiconductors or insulators. Next, we are going to know about due to materials sources of electrical resistance due to material independence. Electrical resistance in materials can vary depending on factors that materials composition, crystal structure, temperature and impurities. For example, conductors like metals have a low resistance due to the abundance of free electrons, while insulators have high resistance due to the limited electron mobility. Next, we are going to semiconductors fall in between and can have their resistance greatly influenced by factors like doping and temperature. And next we are going to, due to temperature dependence, the electrical resistance of materials often changes with temperature. In metals, resistance typically increases with temperature due to increased lattice vibrations which impede the movement of electrons. This relationship is described by the temperature coefficient of resistance TCR. Next, however, in some materials like semiconductors, resistance can decrease with temperature due to increased electrons mobility by thermal energy. Next, we are going to discuss about due to length and cross-sectional area also electrical resistance obtains. The electrical resistance of a conductor is directly proportional to the length and inversely proportional to the cross-sectional area. Here is the formula, that is R is equals to rho L by A. Rho means resistivity, L means length and A means cross-sectional area. The relationship between the formula is this. And next, so longer conductors have higher resistance while semiconductors have lower resistance. Cross-sectional areas have lower resistance. Next, we are going to discuss about resistivity. Due to resistivity, electrical resistance is directly influenced by the due to resistivity of the material through the formula R is equals to rho L by A, where R is the electrical resistance, L is the length of a semiconductor, A is the cross-sectional area of a conductor, rho is the resistivity of the material. Here, resistivity is an intrinsic property in materials that determines how strongly it resists the flow of electrical current. Materials with high resistivity, like insulators, impede the flow of current more efficiently than materials with low resistivity, like conductors. We are going to discuss about due to impurities and defects. Impurities and defects in the materials can significantly affect its electrical resistance. When impurities are introduced into a material, they can disrupt the irregular arrangement of metals, creating localized regions of increasing resistance. Similarly, defects such as vacancies, dissolations, and grain boundaries can hinder the flow of electrons, leading to higher resistance. In semiconductors devices, international doping with impurities can be used to control the electrical properties, but excessive impurities or defects can degrade performance. Next, we are going to discuss about in metals. Impurities can scatter electrons, increasing resistance. The overall impurities and defects play a crucial role in determining the electrical behavior of materials. Next, we are going to discuss about series and parallel current circuits. Due to series and parallel circuits, also electrical resistance obtains. In a series circuit, the total resistance R is the sum of resistances, that is R1 plus R2 plus R3. You know the formula of this. And next, so the series circuit resistance increases as more resistors are added. In a parallel circuit, the reciprocal of the total resistance R is the sum of the reciprocals of the individual resistance. So, in a parallel circuit, the total resistance decreases or more resistors are added. Understanding these principles helps in designing and the circuits to achieve desired electrical characteristics. And next, we are going to due to frequency dependence also. Next, the electrical resistance of a material generally doesn't depend on frequency on a typical direct current circuit. However, in alternating currents AC circuits uh, may appear in very factors like skin and effect and eddy currents in conductors. These effects become more prominent at higher frequencies. And next, we are going to practical applications, heating applications. And heating elements resistance wire is used for heating elements for applications like electrical stoves, water heaters and toasters. The resistance generators heat when current flows through the wire. Lightning, electrical motors, electrical components and sensors, these are the practical applications of sources of electrical resistance. And electrical safety and transmission lines. Next, we are moving to importance of minimizing resistance. Efficiency, we can save efficiency, performance, reliability, safety, cost savings also. Next, we are going to conclusion. In summary, electrical resistance stems for combination of factors including uh, materials impurities, temperature effects, geometric dimensions, intrinsic material properties, and the presence of defects. Understanding the managing Understanding and managing these sources are crucial for designing efficient electrical systems and optimizing conductivity. Thank you for listening.